I'm the developer of the AOPXplorer. Today we're going to show you how to use the AOPXplorer. For those of you who aren't familiar, AOPXplorer is a tool for those who want to visualize data in adverse outcome pathway networks, or as we call them, AOPNs. The AOPXplorer is a Cytoscape app, and it's available for download from the Cytoscape App Store. So I have it installed already in my version of Cytoscape. Here I'll click it to start up Cytoscape. And as it loads, you'll see up here is the AOPXplorer. It just loaded. For AOPXplorer to work properly, you do need to have network access available to you. What the AOPXplorer does is it goes out to a GitHub repository where we have placed several different AOP networks. At this time, we only have 4. We have gastric ulcers, steatosis, selective serotonin reuptake inhibitors, and epilepsy as various kinds of AOP networks. Now you might be thinking the SSRA one sounds a bit chemical specific, and in this case it's a AOP network that we developed based on knowledge of the pharmacology and toxicology of SSRIs such as fluoxetine, for instance. What we're going to do in today's tutorial is we're going to select the steatosis AOP network. This is one that we've been working on recently. And I'll expand the Cytoscape window just a little bit here. And you can see here's a very complicated steatosis AOPN that we developed recently. What we want to do with AOPXplorer, though, is not only allow you to download these AOPNs that we've built at the Army, but we also want to give you the opportunity to visualize your data on top of these AOPNs. So let me just walk you through the process of doing this. We're going to go over here and we're going to export our node table. So find the name of this particular network. In this case, the name of the network is actually AngrishNet with assays. That's a holdover from when we were expanding this from work from another individual. And you want the default node. Click OK. It'll bring up this export table box. Go ahead and go to a place where you want to save it and hit OK. And now what we're going to do is we're going to open that file up in Excel. So let's go here. And here we have the file that we just exported in front of us. You can see it has several different columns. The column that we really care about is the shared name column. This is the column that Cytoscape uses as a key for the table. So all of the names within shared name have to be unique. And this is how we're going to then tell Cytoscape that the data that we have associated with these particular nodes are the ones that are going to be the same names as in our Cytoscape network. So we're going to pretend that we actually have some data here. I'm going to just very quickly make some example data. We're going to assume that in this case we have a dose response. And for our purposes of our example, we're going to say that we have some expression data, possibly gene expression data for PPAR alpha. And we're also going to say that we have some data for HSD17B4. And again, I'm just creating this on the fly. And we also have some data for SCD1. And in this case, it's not really changing. And same thing for mTORC2. It's not really changing at all. So what we see here is as the doses increase, we have for PPAR alpha a net decrease in the expression of that particular gene. Same thing for HSD17B4. Now, if you remember in the network here, we're actually talking about proteins, not genes. So one of the questions you might have is, why are we putting gene expression data on top of what is seemingly protein networks? And this is a fairly common practice. We're making a very large assumption, obviously, that whatever happens at the gene expression level is going to be recapitulated at the protein level. That isn't a big deal for using this as a hypothesis generating framework, which in this case, that's our goal. So what we're going to do is we're going to save this particular file. I'm going to save it in a directory where I can find it rather easily. And then we're going to go back to SciEscape. And we are going to import this file. So go to File, Import, Table, and then File. And you can see here's the file that we just created. Let's hit Open. So now we've been able to import the data into AOPXplorer. You can see that in a lot of cases where we had blanks, it says we have an invalid value. That's okay. Here we can see we have values that, and they have come in for HSD17B4, SCD1, NAPTOR2, PPAR alpha, etc. So things are looking pretty good here. Let's go ahead and let's paint this data onto the node. So the first thing we're going to do is under Style, go to, make sure we're in the node part, go to Image Chart, click over in this box, click on Charts, make sure we move everything over, make sure it's in dose order, as it is here, concentration order, and we're just going to hit Apply. And now you can see we've got these very colorful bar charts here, but I really don't like where they're at, so I'm going to move them. Come over to Paint, go to Custom Paint, Image Chart Position 1, and you can see that adds this new thing right here. Click here, drag this down. That will make sure now that the bar charts are actually centered but below the nodes. And so here we go. We can now see that we've got dose response or concentration response relationships for PPAR alpha and HSDB4, such that as we increase the dose, we have decrease in expression of these particular genes, and under that assumption that we were making earlier, that gene expression relates directly to protein expression, we might anticipate that the activities of these would go down. If the activity HSD17B4 goes down, we may in fact anticipate that we would end up seeing steatosis occur. So here we've given an interview or a overview of how to use AOPXplorer. I hope you found this interesting. If you have any questions, of course, you can always email me. And you can also, if you find bugs, or if you'd like to make feature requests, go to this site right here, github.com/datacybergoon/AOPXplorer-app. Come down to the Issues button, and here you can add a new issue. Issues can be things such as feature requests. They can also be bug issues that you identify. Let us know if you find anything, and we'd be happy to hear from you either way. Thank you very much for your interest in using AOPXplorer. I hope you have a good time with it. And keep in mind, we will be increasing the number of AOP networks that are up on our GitHub site over time. If you are interested in putting up AOP networks, of course, you can always contact us. And we are more than happy to allow others to host their AOP networks that they have up on our GitHub site so that it can be used in AOPXplorer. Just shoot me an email or let me know. You can go to this particular URL here, github.com/datacybergoon AOP_networks. Come here, you can you can add an issue if you have an AOP network that you'd like us to include. Then you can either email it to us, or you can possibly have your own GitHub repository where you put up your AOPNs, and we could do a pull request that way. All right, thank you very much for your interest and your time. And again, if you have any questions, you can always email me at lyle.d.burgoon@usace.army.mil. Thank you, and have a great day.